available to all of you. So we're recording today's session on the Criticality Dilemma with Tyler Evans, and we'll share the recording to all of our listeners today. And also, Tyler has agreed to share his slides, so we will share those at the conclusion of the webinar via email. And we will have a survey at the end, and so those of you that do have additional questions will be able to do so. Tyler has agreed to stay at the end of his presentation till the top of the hour and answer your questions. And please feel free to post them in the questions feature at GoToWebinar at any time, and Tyler and I will attempt to answer them at the end of the session. So without further ado, Tyler, take it away.
Hey, thanks, Rona. So, guys, I want to talk about our agenda and our goals. We want to talk about culture and how criticality touches and drives our culture of world-class reliability. And also, the reason we're talking a little bit more about criticality is because sustaining and scaling your maintenance program is the really hard part. Some of us are at a certain point of our journey where we just got through starting up a program and we're breathing heavy and thinking, glad that's over, it's smooth sailing from here on out. But I'm here to warn you and to support you that it's not. The real work is in sustaining the program and scaling the program. And we're going to talk about how sustaining the program can sometimes get thwarted and confounded, and you run into barriers. And then really, frankly, we want to talk about the relationship between culture and tools. Now, this is tools with a capital T. This is not a sales pitch for Fluke tools, but this is literally talking about tools in the broadest sense, like even just the way you organize yourself, the way you schedule yourself, the way you the types of tools and practices you choose. Throughout history, tools have defined culture, whether it's the Bronze Age, the Stone Age, the Industrial Revolution, whether you want to start breaking it down into Industrial Revolution 1, 2, 3, the technology age. Our tools define our culture. And so we're going to talk about some very specific tools in the form of practices. Again, tools with a capital T, not individual products. And so I'm not going to spend a lot of time on this, but the goal of our maintenance teams should be to move towards the right. We want to move away from reactive maintenance and move toward predictive maintenance. If anybody on this webinar has questions about these terms or is new to these terms, there's a lot of information on the internet that really lays out very well the difference between these three. We're trying to get predictive because predictive helps avoid more downtime. It avoids cost, and it helps us move more reliably. I believe there's also some eMaint webinar material that covers this, so you can find that on the website. But really, I want to dive into criticality. Now, a lot of people on the phone here are going to know criticality, so I just need to provide this little basic overview to get everybody on the same page. Again, there's a lot of information on the web all about criticality. The idea is that not all of your assets are equal. And so some assets are more important to keep from breaking down than others. And so what you can do is a typical criticality analysis would be you look at all of your assets or systems and you begin to score them. For example, you might use a 1 to 5 scoring. And you start with safety, and you say, if this machine breaks down, what kind of a safety risk does that pose to people? And a lot of assets might just be a very low safety risk, but some might represent a real serious safety risk if they break down. And then the next three talk about how much does downtime of this asset affect the total downtime of a machine or of an entire system or an assembly line or something, or the entire plant. And so you can give each asset a kind of a score, maybe a 1 to 5 or a 1 to 12. There's lots of ways to do this, and the internet is replete with suggestions on how to perform this. But then you might also factor in some things like, if this breaks down, how expensive is it going to be to repair it? Sometimes that's so expensive that you want to avoid a breakdown at all costs. Other times, the time to repair. This is especially an issue with older assets where spare parts aren't readily available, where things need to be custom made, or very large assets. Just picture a 2,000 horsepower electric motor is not just available to buy online. That usually is a special order with weeks, maybe even months of lead time. And then there's another piece about compliance risk. If this particular fan breaks down, am I now breaking various environmental and air quality laws? If this particular machine or pump breaks down, am I now not putting enough catalyst into my tank, and so now I'm producing a toxic chemical that's going to need to be disposed of with special hazmat procedures? Compliance risk is also a big driver of criticality. Now, on the right, I have two examples of your criticality score. So each asset will have a total, at the very bottom of this list, every asset will get a total, and that represents the criticality score. And so you can imagine then ranking all of your assets in terms of their criticality score. You might have a plant that looks a little bit more like the picture on the top, where there's sort of this gradually descending criticality, or you might have a situation on the bottom where there's a collection of things that are really clearly very high criticality, and then there's some other collection of things or a long tail of things that are less critical. And now this actually begins to tee up the criticality dilemma. So there's a lot of different strategies for managing risk among critical assets. One is, if you want to avoid having a breakdown, have a cascade effect and take down your plant, you can modify the asset. You can find the weak link in the asset and replace that part, make it stronger, make it less likely to break. Do something in the design. This is where engineers can get involved to make an asset more reliable. You can also do asset redundancy. You can have, instead of having one single pump that pumps 100 gallons a minute, you could have two pumps in parallel that pump 50 gallons a minute. And that can actually help make it so that if one pump breaks down, you're not all the way out. You can also keep some spare assets on standby. Some critical assets, it may be worth keeping an entire spare asset in your storeroom or ready to be replaced. A twist on that is maybe you have 200 gallon per minute pumps, and one is always turned off and another one is running, and you can switch back and forth at any time. Another piece here is related to number 2 and 3 is asset standardization. If you can get a bunch of pumps all to be the same kind of pump, then it's easier to just hold one extra pump in inventory, and that one extra pump can cover many pumps in many different places in your facility. Obviously you can keep spare parts inventory on hand. For some more advanced or more expensive assets, sometimes the manufacturer of the asset can actually offer contracts and services where they take charge of making sure that the asset is always running well and always operating. Another one here is called over-specification. That is where you might say, well, I want this thing is spec'd to have a certain capacity, and we don't want to be operating at the edge of that capacity. So we actually want to use a bigger or stronger or higher output asset. Now, a warning here, electric motors especially, it can actually be damaging to a motor to run it at too far under the load. So with an electric motor, you can't just double the horsepower from what you need. So you have to be careful about that. But there's lots of other things, valves and pressure gauges and all sorts of things that can just be over-specified for the sake of having a safety factor or a margin of error. Now, most of the things 1 through 6 are very expensive, and they usually require a significant amount of money, either in the form of paying money or in the form of locking up money in terms of inventory. Now, the 2 on the bottom are usually just have to do with labor, and that's why these are so popular, and that's why these are seen as such a cost-effective way to be reliable, is to use preventive maintenance practices and condition-based maintenance practices to avoid downtime and to keep your assets running and to keep your critical assets from breaking down. So now with these two, with this kind of background in criticality, we're ready to really dive into this criticality dilemma. So there's a bunch of, this criticality idea starts to lead to a bunch of self-defeating wrong philosophies about criticality. The first one is that people are tempted to think of their criticality list in a binary way, right? Either 1 or 0. And they choose one single cutoff line. And they decide everything above that line we have time to manage and take really good care of and do best practices. And everything below this line just isn't important. And so the problem with this mentality is, where do you draw that line? Is it, is it between 10 and 11? Is it between 5 and 6? Is it between 14 and 15? The real problem with this is things below that cutoff line are still going to break down. And once those things break down, we go back into reactive mode. They're still critical. They still cause problems for the rest of the plant, and so we end up firefighting those neglected assets, and that drags our whole program back down into a reactive mode, and we lose a bunch of the progress we've made. The next way to think about this is really just a variation of number 1. It's a dynamic view, and we say, well, as long as every asset is force ranked and stacked in the right order, then we can just maintain as many assets as we have time to maintain each week. So if I've got time for 20 assets this week because I'm really busy doing other important things, then I'll get the 20 most important assets for sure. And next week, if I've got time to take care of 100 assets, then at least I'll know I'm getting the 100 most important assets. This is actually a problem, though, because it has the same problem as number 1. Whatever assets are getting neglected are exactly the ones that end up breaking down, and those are the ones that end up causing problems and dragging us back into reactive and taking our time away from being able to maintain the even more critical assets, and so really everything starts getting neglected. The other one here, the next one is what I call the infinite schedule. And it's this idea that as long as I have a reminder somewhere in my system, right, as long as I'm promising to eventually maintain this asset, this is okay. And when we have more assets than we are even able to cover, there's a temptation to just use schedule as a way to dilute and spread out our maintenance. I have to pause here because this is an eMaint webinar. I need to be crystal clear that maintenance scheduling is a foundational cornerstone of any well-run maintenance program. The difference here is we're talking about not confusing scheduled maintenance for sufficient maintenance, right? So we don't want to let our ability to schedule things as far out as we want to actually enable us to justify under-maintaining our assets. So again, we're still stuck in this, how do I possibly maintain all of my assets with my limited resources? And I'm posing this as a temptation. Many on the line here may feel this is just reality. I mean, I can't schedule 100 assets in one day. And so trust me, we're getting to a better solution here. But I want everybody to understand the slippery slope of the infinite schedule problem. And then lastly is this idea, this philosophy of full coverage. It says, look, all of these assets are critical in some way, and we don't have enough resources to cover them. So really the only way to get to a world-class maintenance program is we need to double our investment in maintenance. We need to staff up. We need to buy all the most expensive and elaborate tools. And there's this, I've captured in the quote down below, unless I have full staff and full budget, we're never going to get ahead, and we're never going to win, and it's not even worth trying. So this philosophy is also pretty common, especially amongst maintenance teams that have slipped or tripped or run into problems in the past. This is sort of a resigned philosophy. And I just want to point out that this will smother any spark of a reliability culture. This idea that excellent maintenance is outside of our control is usually a lie, and is usually something that will further feed a bad culture. And it assumes that improvement is always outside of our control. So all of these philosophies, these 4 self-defeating practices, they make us inflexible, and they make a maintenance program unsustainable. And really, these are all just reflections of a common problem in maintenance, and that is we have more critical assets than we have capacity to manage. And so that's the heart of this problem. That's what I really want to focus on here. And so with this idea in our mind, managing capacity, I just want to introduce one more idea before we get to the proposed solution. And that is that we used to take a very simplified approach to criticality. If you see this little diagram up here, at the very left-hand side, you see we used to just see things as either critical or non-critical. And I'm going to suggest that we start actually adding a little bit more nuance to our view of criticality and start seeing things as non-critical, semi-critical, critical, and then a term that I use, this is just my own term, is a star athlete. And I've added a little definition here on the right-hand side for everybody to see how I define these different assets. And I think the most important thing is the difference between a star athlete and a critical asset. A star athlete is any kind of asset for which a percentage change in performance or a percentage improvement in performance equals a percentage change in revenue, right? Now, a critical asset is much easier to think about. It's when the machine is running, we're making money. When the machine is not running, we're not making money. And so this is just, just on versus off. Star athlete is about every little incremental bit of improvement. So a great example of a star athlete might be a turbine generator, right? It's like Star Trek for a turbine generator. Every additional percentage of improvement and efficiency they can get out of that generator brings instant dollars to the bottom line. Then there's semi-critical assets where when something goes down, it doesn't really shut down the process, it just puts some strain on the process. A really classic example I use a lot is forklifts. Your facility might have 3 forklifts, so if one of those breaks down, the other 2 have to work 50% harder, but you're still running, and you've still got time to wait for repair parts to come to fix the forklift. So we can go on from here, but this is where we start talking about the solution to the criticality dilemma, because the criticality dilemma is not just confined to maintenance. In fact, other industries have this same problem. In the healthcare world, healthcare workers have been grappling with this problem for decades and decades and decades, right? If you think of a medical patient as an asset, that's a really good analogy for maintenance. Think about it, at a hospital, every single asset or patient is equally important. Their criticality analysis shows every single bar all the way at the top. And they have limited resources. So either they could create a cut line like one of these other four self-defeating practices and just say, well, you're not important, so we're not going to take care of you, but you over there, you're important, so we're going to take care of you. That's clearly unacceptable. Nobody would stand for that. Or they might take the approach, the only way to do this is to build up this super vast pool of resources so that we can give every single person 100% care all the time. And that's unsustainable. In fact, cost of healthcare and quality of care is actually a big raging debate right now in the healthcare world. But what they've done is they've created this fascinating, powerful model that helps them maximize patient coverage and patient care with minimal resources. They use what's called a tiered approach. And the tiered approach is something we're all familiar with. It is, we all go to the doctor and first we see a nurse. If the nurse can solve our problem and fix us and return us to work, then the nurse solves the problem. If the nurse can't figure out what's wrong, then the nurse can escalate us or refer us to a general practice doctor. The general practice doctor is more qualified and has more advanced tools and has more skill and experience and training. And if they're able to solve our problem, they solve us and get us back to work and send us home. But when they can't figure us out, when they can't figure out what's wrong, when they can't diagnose the problem, they'll refer us or escalate us to a specialist doctor who knows exactly that specific type of problem or that specific set of symptoms. And they have all the most advanced tools, and they spend all of their time highly focused in that one domain of that problem. And this is how we get tiered levels of training, tiered levels of workers and employees, and a tiered volume of visits. Think how many people the nurses are seeing versus the specialists. And a tiered amount of time and money and resources spent on each of us. So this helps us not waste a specialist time just when we have a cold. So really, you can see how this might, you're already probably seeing how this could apply in an industrial setting. And that is, this chart here shows how tiered maintenance would work, and tiered maintenance helps us solve the criticality dilemma, is by using simple screening practices for all of our assets as an initial first tier. We're able to do fast condition-based screening on all of our assets. And then only when we find assets that are showing signs of trouble do we escalate those for exception-based diagnosis. And so then we can use more advanced tools. We can spend a little bit more time focusing on that asset. And then if we run into a real problem that we don't know how to solve, we can call in a specialist. Now over here on the right, there's different practices that can be applied. So a non-critical asset, probably isn't worth our time for for diagnosis or analysis. You just screen it, and if it's good, it's good. If it's bad, you replace it or don't replace it, whatever's needed. For a semi-critical asset, you might screen it, and if it has a problem, you might diagnose it, but you wouldn't spend time doing a big, deep analysis. You'd just fix it. Critical assets are unique because they really span this whole tiered maintenance approach. And critical assets are really where this tiered maintenance approach can help so much. And star athletes, you usually just analyze them, give them full, deep analysis all the time on a regular basis, regardless of whether they're healthy or not. So I want to just show that different tools can enable tiered maintenance. In the world of vibration, that's the world I've spent a lot of time. There used to really be only two options. You either had a really cheap, simplistic vibration pen, or you had a super advanced vibration meter. But now there's tools that can be used by different skill level people and provide different results. So if we go in reverse order, you can imagine number 3 could be a really fast screening tool for all of your assets. And number 2 could be a general purpose diagnostic tool. And number 1 could be an advanced analysis tool. And so these require different skill levels, and they require a different amount of time invested to perform an analysis. And so these tools, again, this is a graphic I have. This isn't a sales pitch for Fluke tools, but the theory here is that you can screen all of your machines, diagnose the ones that need extra attention, perform the corrective measures, and assign those corrective work orders for the machines on an exception basis, and then use some of those same screening tools to verify and report that the machine is back to good working order. This is another diagram of how that might work in a tiered maintenance situation, and I'll just kind of skip through this. But you can imagine that just like the nurse, sometimes you can solve the problem and just return right back to working condition without having to escalate up the pyramid. But this is really a vision. This slide here is a vision that I'd really like all of us to see, and that is, if you can connect all of your handheld, route-based tools into one cloud system, all that data can be put in one place. And that really enables a tiered maintenance program where people at all 3 levels now have access to that data. The analogy here is hospitals and healthcare systems have been reaping huge benefits from digitizing patient records. And these assets are just like patients. And so if you can get all of the data from all of these machines into one place, then everybody can view them, and maintenance is much more efficient. But we don't just use handheld tools. Also, if you can connect all of your sensors, things that are already installed and mounted on your machines, if you can connect those also into the same system, then you'll have even more access and more transparency and more context. And then if that data is all feeding into your work execution system, then imagine, alarms on a sensor can automatically trigger work orders that automatically send someone out to go do a more advanced diagnosis. So in many cases, the fixed installed sensors are really operating only at a screening level. They're helping you cover a broader base of assets with basic screening, and lets an asset or a machine sort of raise its hand and call for help when it needs some help. And that can instantly trigger a work order that sends somebody out with a more advanced tool, like maybe a more advanced handheld tool. This is a vision that Fluke and eMaint are really committed to bringing together and bringing to the world. And so you could imagine that if you had all that data in one place, you'd be able to see an all-up view of all of your assets and what assets you're covering and what their status is, how many of those assets are condition red versus green. And then you'd be able to drill down and look at specific assets and see how their condition has been changing over time. Most of these assets are following that standard, was green, then went to yellow, then went to red, but then we repaired it and now it's green again. But if you look at that third asset down there, that's really doing some funny stuff. And so that's another one you might want to drill in on and read the comments that have been entered by the technicians. Or you might want to look at the complete health history of all the different data and all the different tool types and all the different measurements that have been taken on that machine. And then you could even drill into a specific measurement and look at the details of that measurement, or look at the detailed thermal image, or look at a trend line of amperage change over time. But the beauty of this kind of a system is I've shown it to you, walked you through it from kind of a top down, but really this kind of a system would build up naturally from the bottom up. As people take measurements and record those measurements into a central cloud system, those measurements automatically get assigned to assets and machines and build that health record. And that health record automatically builds a trend record of the condition. And that trend record of the condition across all of those machines builds this sort of top-level plant-wide dashboard. And so really this software lets you automate all of this from the bottom up just by doing the same kind of maintenance routines that you're already doing today. Now I want to talk about, I have to give one more warning about criticality. So once we recognize that we've got a lot of critical assets, and the most cost-effective way to maintain those assets is by using preventive and predictive condition-based maintenance practices, we start to realize that we don't have enough resources to do maximum data analysis on every machine. And that's where tiered maintenance comes in. But I want to use an analogy here of riding a bike. I have 3 kids, and riding a bike is sort of this universal rite of passage that probably so many of us have gone through. In this analogy, I want to be careful. In this analogy, the child riding a bike isn't any of us. It's actually our program. And the parent is more like all of us on the maintenance team. We're all trying to shepherd this program and nurture it and make it sort of self-sustaining and make it work on its own. And a lot of maintenance programs really struggle, and they fail, or they fall and then restart, and then fail and then restart. And this cycle is really frustrating for a lot of teams. And one of my colleagues taught me a principle that I think is very powerful, and that is how we sequence the assets that we begin maintaining. So criticality would tell us we need to start with our most complex, most critical assets. But those are the assets that are toughest to maintain. Now, the analogy here in cycling is that there's another way to learn how to ride a bike, and that is by using a balance bike. And balance bikes teach kids how to balance first and then pedal later. Whereas in the traditional model, we have a bicycle with training wheels that keeps us from learning how to balance and focuses just on learning how to pedal. But balancing is more important than pedaling. And so a lot of times we sort of build up a system, and it's based around our most complicated assets and our most advanced analysis, and then we try to scale it and the system falls apart. But does anybody in the sound of my voice have any doubt that the child on the far right is going to have any trouble learning how to pedal his bicycle? So by analogy here, we want to build a culture first, and a set of operating practices and patterns and habits, not necessarily starting with the most complex analysis. So when we start with the most complex assets in our company, we usually end up assigning one single super expert with the most complex and advanced tools that nobody else knows how to use. And this is actually the opposite of building a reliability culture. It builds a reliability island and a pet project. And these are very unsustainable. But if you use a tiered maintenance mentality to start with easy assets and build in those patterns and habits and work practices, you're just like that kid on the very far right here. No one has any doubt that in a well-functioning program, you'll be able to add a more complex asset and take that on. And so a really important trick to starting and maintaining and sustaining a reliability program is to start with your mid-tier or your easy assets first and work your way up. Now some people might say, but my most critical asset is also really complex. That's great. Keep maintaining that asset the way you've always done, whether that's using a third-party service provider or using the manufacturer. Just keep doing that and don't pull that into your program yet until you've got the habits and practices and standard procedures in place. So here's the final overview. Is one, criticality analysis is a really important way for you to figure out where your priorities are and how you need to be addressing your assets. But remember that little strip on the right-hand side of the tiered maintenance model. The best purpose of criticality analysis is to tell you how you should be maintaining every asset, not trying to tell you which assets you should maintain and which assets you should not maintain. And then we talked about all the different strategies: redundancy, spare parts, vendor-managed uptime, all these other ways. Usually condition-based maintenance is the most cost-effective. The only problem is that it requires a lot of labor. So instead of spending money, you're spending labor. And this is where the criticality dilemma comes in, because we don't have enough people to cover all of our assets. And that's why tiered maintenance helps relieve that pressure by letting us spend our labor more intelligently. And so tiered maintenance is this really powerful hybrid model where you're using condition-based maintenance at the bottom level to do screening across all of your assets, and then you're using exception-based maintenance for your more advanced analysis and your assets that are showing problems and trouble. And then finally, being able to put all of that data into one single place and getting everybody along that tiered maintenance pyramid viewing the same data, having access to the same data, and being on the same page is a tool that really helps build a department-wide culture instead of locking up all of that knowledge and expertise into one single person who can take a job somewhere else at any minute. So that was my presentation. All of these slides are going to be available. I hope my presentation has sparked some questions and comments, and we want to just make it clear that you can learn more by going to flukeconnect.com. You can also go to connect.fluke.com, and you can always go to eMaint.com. So I'll actually turn it back over to Rona to see if there's any questions for me.
Yeah, thanks, Tyler. And please just go ahead and type your questions, any additional questions, into the questions feature and go to webinar. And again, we will be sharing a link to both the recording and also sharing the slide deck with our viewers today. Maybe you can start, Tyler, while people are formulating questions. You built kind of the case for employing this strategy. Do you have maybe some examples of some kind of ROI improvements, that you can, examples that you've seen or heard of where people move from a more reactive and preventive toward a predictive? Because this is going to be, anytime there's a change, someone's going to want to know, what is some of the the payback in time and resources.
That's
examples you can share?
Yeah, that's a really, you're right, that's a universal question, and that's something lots of people are looking for. I think in my experience, what I find as companies are taking this journey away from reactive maintenance more toward proactive and predictive maintenance is a lot of times companies aren't always measuring the KPIs that can reveal the value of preventive and predictive maintenance. So a lot of times when things break down, we rush to fix them and we just accept breakdowns as a normal part of getting work done and breaking through barriers and finding solutions. But really, when you start a program, there's a lot of pressure to show results quick, especially when it requires an investment. This is why that last self-defeating, number 4, self-defeating practice of saying, I need full budget, I need to ramp up, I need to buy all the most expensive tools. This is also self-defeating because this kind of upfront investment naturally draws a bunch of management attention and a lot of managerial impatience for ROI. So sometimes by not adopting a tiered maintenance program and by not starting small and working up, we're actually creating a scenario where we're learning how to deliver ROI slower than maintenance wants to see the ROI. Some of the ROI examples that come to mind are throughput. I mean, eliminating downtime eliminates throughput. The other thing is overtime. Whenever machines break down, maintenance teams have to work overtime. They have to work around the clock to get it back up and running. Or production teams have to work overtime in order to make up for the lost time. So overtime and throughput are 2 very important KPIs or metrics that prove ROI. There's a lot more, and I think there's I think there's a lot of discussion on the web about ROI. If somebody wants to talk more about this, they can absolutely email me and we can have a broader discussion.
Excellent. I appreciate that. And it sounds like what you're describing is often what we describe team and clients start with a pilot. And that's kind of the beauty of SaaS-based. There's some of these tools that are less costly that you can kind of prove the concept in a pilot on your own ROI and then start to build upon it.
Without committing to infinite spend and infinite ramp up from day one. That's exactly like the analogy of the bicycle, of like taking those training wheels off, doing a big investment. Now we've got this pedal bicycle. Now let go and see if it lives or dies.
Somebody asked a question about, let me pull it up here, a clarification on that top tier, the star athlete definition. And they said that the way you've described it, for that to work, demand has to always be greater than supply, which is sometimes hard to prove on the revenue side.
Yeah,
so
great point.
Would you include, he suggested that perhaps you refine that and include a star athlete sub-definition with percent of improvement equals percentage improvement in cost of sales, or just
yes, absolutely. That's a really powerful point. So in my example of a turbine generator, you can imagine that's a situation where there's usually demand is always higher than supply, and so every additional piece of productivity you can squeeze out of the asset, you can collect money on that. I think your tweak, this listener's tweak is very wise, and I should say there's even more ways you can tweak this. This was only supposed to be an example. Another example of how this can be tweaked is some people work for a government facility, right? Maybe they manage the facility maintenance at a government building where there is no profit, right? It's all nonprofit. And you can still say, that this how does this affect our ability to meet our service level agreements, or how does this affect our ability to fulfill our mission, and how does it affect our ability to deliver at the best cost as this person provided. But I think the real important point is just star athletes are where we're worried about percentage performance, not just whether the machine is running or not running. And then the last thing I would say is I didn't explain where the term star athlete comes from, but it's really trying to draw on this healthcare analogy. And all of us on the phone here today are normal people, and so we only get medical attention when something hurts or when something is ill. But a star athlete gets an MRI scan every month on the third Wednesday on a regular schedule. They get advanced analysis regardless of whether they're healthy or sick, because that's how you maintain a star athlete. That's why the star athlete only sits at the top of the pyramid. They're always getting advanced analysis all the time. And a lot of times when we build up a program, we start with only the most advanced tools and there's only a super expert, and we try to scale this advanced top-tier maintenance method all the way down to all of our assets, and that's just completely unscalable.
Mm-hmm. That's a good analogy. We did have some listeners asking about specific examples of how data gets into, if they're using monitoring today or SCADA, can that be integrated into this scenario? And I guess the short answer is yes, and what we'll do is we'll have a survey at the end, and those who have specific questions about Fluke and eMaint products, we'll ask you to kind of check a little box, and we can get product specialists speaking to you about those solutions. These
are the questions that kill us, because the answer is yes. And there's pieces of that puzzle that we're able to talk about today, and there's other pieces of that puzzle that are on the very, very near-term horizon, but we're not allowed to talk about solutions and products before they launch. Mm-hmm. However, if you reach out to the Fluke Connect team or the eMaint team, they can give you a more complete view of what is on the near-term horizon.
Correct. And we are doing this today, perhaps not in the fully automated fashion that we're envisioning. So yes, we can certainly tell you about what we did today and the journey we're on. Someone is asking, how do you consider predictive time for battery replacements in UPS units?
Oh wow, that is a question that Fluke has answers to. I am not the right person to do that. We have a battery tester product with a subject matter expert in battery testing. If you respond to the survey at the end, we can absolutely connect you to an application specialist in battery testing who can answer those kinds of questions for you.
Okay, perfect.
Anything I answer would be automatically wrong from the minute it came out of my mouth.
The vibration is your expertise. You described in your first slide too, in doing this in this classification system, who typically, I don't think you can do this in a vacuum. You probably do want to get a range of input and perspective. So when you've seen people do this kind of tiering and scoring model, maybe you can give some tips to our listeners on who are the right people to include or to consider including in that classification.
Well, that's a very wise question. I appreciate that. Criticality is really one of those places where the maintenance function really touches and influences the operations function. This concept of which assets matter the most when they go down is a question that probably has to be answered together or scored together between the maintenance manager and the plant manager or the operations manager or whoever it is who's really in charge of that production at the end of the day. And I keep saying production, but I think we can all imagine, in a commercial facility, it's service level agreements or the mission of the facility, whatever. At a university, it would be something else. But really, this needs to be operations and maintenance working together. Now, the frontline technicians can also participate in this. This is great. They provide more perspective around the cost and difficulty to repair and the time it takes to get parts in. But they would provide less input about, how important is this one machine to our company's mission, to our goals, to our ability to generate profit. And so really this could be a cross-functional discussion. But I'd say the two that you'd have to have are maintenance management and operations management.
Very good. Well, Tyler, thank you so much for putting this together and for all your insights and for taking your, I know, very limited time that you spend in the office to sit down next to us next to me and join all our listeners today, and I really do appreciate it. And
well, I'm grateful for everybody tuning in, and I hope I was able to answer your questions. I appreciate it. These were fantastic questions. And all of these slides will be available to reference and to sort of tweak or modify for your own circumstances. I hope it's thought-provoking, and thank you.
Great, and it helps you kind of understand the mission that we're on, and we really do value your feedback. So as soon as I end the webinar here in the next minute, there'll be a brief survey that will pop up. Please let us know how we're doing. What other topics can we bring to you? We have such a wealth of people like Tyler and others on the team and our industry partners. And what's really keeping you up at night, and what other kinds of what other vision can we share? What other challenges can we help you think about a little bit differently?
And even if it's not a topic that we have an expert on, we will reach out and get an independent expert to come in and cover these topics.
Absolutely. So please don't let the dialogue end here. And we do offer these sessions monthly, and give us your feedback on topics. And so again, until we see you the next time, Tyler, take care, and thanks to all our listeners. And we'll see you again soon. Have a great day.